welcome, and I hope you've had a very informative couple days. My name is Jeff Lawrence. I'm the Executive Vice President of the Center for Economic Growth in Albany. We're a regional, membership-driven economic development organization with over 300 C-level members that represent advanced manufacturing, industry, education, not-for-profits, hospitals, and government. So we're pretty broad-based with a three-point mission. And that mission is to grow existing technology and advanced manufacturing companies, to attract new technology companies and investment into the area, and to prepare the area for technological growth. So I've been doing this for about 20 years, and being able to see the changes that are going around here in the region is really fulfilling, and I have one of the greatest jobs in the world, because it's a great place to be right now, as you've all witnessed. What we're going to talk about today is really focused on workforce, and that's important to all three phases of our mission. We can't grow existing companies if they can't find the talent and skills they need to fulfill their workforce needs. We won't be able to attract new business into this region if the region can't prepare the type of worker with the STEM and 21st century skills that these new technological businesses require. And preparing the region for technological growth, that's really important. And it's a complicated issue. It's partially a marketing issue. We have to get messages down into the high schools and to parents and teachers and let them know about these careers. But we have a great panel that have far more expertise in this area than I profess to. I barely made it through school. And we're going to turn it over to the panel, and they'll talk about some very interesting collaborations, how they work together in partnership to address this problem. So our first panelist is Trudy Lehner, who's the Senior Director for Marketing and Government Affairs at Superpower. Next to Trudy is Dan Ebert, who's the Principal and Chief Academic Officer at Tech Valley High School. Following Daniel is Dr. Quentin Bullock, President of Schenectady County Community College. Then there's Dr. Laura Schweitzer, President of Union Graduate College. And Chuck Steiner, who's the President of the Chamber of Schenectady County. Now I'm going to turn it over to the panelists, and they each get a couple minutes to talk about who they are, themselves, their organization, and how they relate to this panel topic. Trudy.
Thank you. The reason I'm on this panel is because we have been very interested in workforce right since we formed Superpower. Superpower is 13 years old this year, and we were formed, as you heard today, out of Intermagnetics General Corporation to focus on the development and commercialization of what we call 2G HTS, second generation high temperature superconductors, a new type of superconducting wire. A new technology that at that time was really revolutionary. You have to think at that time there was no global foundries here. CNSE, as you heard this morning, was really just a thought at that point. So the type of workforce that we would need excuse me, for this business as it would grow the way we expected it to grow was not available here. When we first formed the company, we were about 20 people that came out of Intermagnetics. We moved into a facility in Schenectady. We had some base technology that we licensed from Los Alamos, from Lucent, and from some other organizations. And we had some very smart people who were working on the science to continue that development. But they couldn't do that all themselves. We needed people to work on the vacuum systems, on the thin film deposition, and so forth. So what we started to do really is scour the world for experts in this field. And we brought in people from China, we brought in people from Korea, we brought in people from India. And as you can well imagine, it's very time consuming to do that. It is also very expensive to bring people in from other parts of the world. But when you're looking for the real intelligent, deep thinking level scientists, you can do that. We were thinking, though, this is a technology that should really be able to have an enormous market potential, because as we heard this morning in some of the panel discussions, especially in the energy technology field, there is a constant demand for more electricity. We're an electricity-based society at this point, and it just gets more and more so. We also learned that we have one of the oldest grid infrastructures in the world, especially in New York State. That's a good thing and that's a bad thing. But what we saw there was that it was an opportunity. With a new technology such as superconductivity, there should be huge business. So if you have the science in place and you start working on the commercialization of the manufacturing of the product, ultimately you're going to need people to do the production on the wire, and those are technician level people and engineers. Where are you going to get all those people from? Are you going to scour the world for them all the time? So we could see right away that this was going to be an issue that we would have to address, and we would have to address it pretty quickly. So at Superpower, we started thinking about, well, how do you do that? And we've reached out to a lot of the academic institutions in the area to start talking about, well, what are some of the ways that we can do that? And one of the initial places we talked to was Schenectady County Community College. Certainly an institution that is used to thinking about developing a workforce for local industry. And they were very quick about adapting to different needs. We also started talking to Union College because we knew we needed a lot of engineers, and their engineering programs are second to none. We have worked very closely together with the University at Albany, the Nanotech Center. And aside from thinking about that level, we started thinking about, well, where do those students come from who are at the colleges? They don't just decide the minute that they graduate from high school that they want to be an engineer. They start thinking about those things when they're in elementary school, when they're in middle school, when they're in high school. So you really have to think about building a pipeline of those workers. And as Jeff mentioned, STEM education has become something very important in this region, where you start with the kids in elementary school and even before elementary school. Pradeep talked this morning about engaging the students in science topics, in math topics, and it's through museums, it's through programs in elementary schools. So these are some of the things that Superpower has been doing right from the very beginning. We work with Tech Valley High School, and Dan is going to tell you about some of the things that we have done together there. We have a very successful program with the community college. In fact, they have a program on nanoscale technology that Dr. Bullock will talk about. We work very closely with Union Graduate College and also Union College to develop the programs there as well. And then, not to shortchange, but CEG, the chambers and so forth have also been very, very important in that, not just in the workforce development part of it, because they have things like job fairs, they have STEM education and workforce development programs that they institute, they lead, and they promote. But also we work with the community, so organizations like the Chamber of Schenectady, the Chamber of Albany County, and those types of organizations help to lead us through and make the connections with the partners. And that's what I think we've spent more time talking about today than anything else. It's those partnerships that help us to succeed. We, as a small company, Superpower, can't do this by ourselves. So we have partnered with academia, we have partnered with government. You heard about many of the government programs that we're involved with. We don't do any of those ourselves. We do them together with the national labs. We do them with funding from the DOE, from the DOD, from the Air Force, and so on and so forth. And that's what's really helped us to get to where we are today. Today, in this region, you can see that we have wonderful technologies, and that really gives us another challenge, because we're really glad that we put these programs together with the schools, but what we're finding is Global Foundries and Albany Nanotech, they're starting to draw from the same pool of students working to build. So that's a good thing and that's a bad thing. But basically, we're looking at it as a good thing and hoping that this type of effort continues, not just with Superpower, but with those other companies as well. So, thank you.
Dan?
Thank you. So I'll try to say three things, and primarily about the academic program at Tech Valley High School. So currently, what you need to know about our school is a regional public high school. So we're not a charter school, we're not a private school. We're a school that's operated by two BOCES, the Capital Region BOCES and Questar 3 BOCES. We're currently located on the east campus of U Albany and soon to locate in a year or so over here at CNSE, which we could not be more excited about. Our mission is to build it for the students who are there and to share what we're learning. The purpose of the school is to be a model for high school education, not the model. And Tech Valley High School is one of 120 high schools across the country in a national network of schools called the New Tech Network. If you want to Google that, you can see the map of where those schools are located across the country. A lot in Indiana, Michigan, Texas, California, and other rights. We're currently the only one in New York State, but we hope to change that. So serving as a model for reform and improvement. So, three things. Teach to skills and content, keep the pipeline open, and engage in STEM. Okay? So, teaching to skills, content, pipeline open, and engagement in STEM. So, one of the things that purposely we need to do that's different, in my opinion, is to teach deliberately to a set of skills that everyone, from Superpower to all the folks at CEG and the folks who helped form the school, routinely say. It goes like this. So, at Job Outlook for 2013, National Association of Colleges and Employers, what are the skills they need, students need? Verbally communicate with persons in and outside the organization, work on a team, solve problems, prioritize their work, obtain and process information, analyze quantitative data. Then it says technical knowledge related to the job. All right? Yes, content is important. You can't think critically about nothing. You have to have content, but it's skills and content. So we have to teach deliberately to those skills, which I'll say more about in a moment. Second is, or how to do that, I'll say more about. How to keep the STEM pipeline open. So here's what you need to know about New York State. You got the pipeline in 9th grade. It's open like this. 275,747 students sat for Algebra 1. It's a Regents exam. Every hapless, pimple-faced student in New York State has to take and pass that exam to graduate from high school. Got it. Got them all. 275,000. Right? So if you want all those kids prepared for STEM, or a significant portion of them, you should have something left over at the end of 12th grade, right? So here's what we do in New York State. Those who go on to the second level of math, which is geometry, right? 161,494. So we just cut in half the number of students who are going on to be prepared for STEM from 9th grade to 10th grade. I'm condensing here a little bit, but you're going to get my illustration. This is SED statistics. Third level of math, Algebra 2 trigonometry, right? 84,947, right? So we've gone from 274,000 in 9th grade, approximately, to 84,000 in 11th grade, geometry. On to physics, right? Primarily a 12th grade course in New York State, 48,772. Okay? 82% pass rate on that exam. Takes it down to 39,018 students ready, right, prepared for content in math and science. 14% of what you started. So in New York State, we're constricting the pipeline ourselves. Okay, we're doing it to ourselves, primarily out of fear, because every principal and teacher is being evaluated on the scores of those exams, and if geometry, algebra, and physics aren't required, guess what? They don't take them. Okay? Pass rate goes up. All right? So, how do you keep it open? Why not? All right? So the answer isn't just to demand more of our students that they take more math and science. Yes, it is. You have to keep the pipeline open. You do have to teach it. But it's also about improving the quality of instruction. So, great article in New York Times in 2011, why science majors change their mind. Okay, I'm making an analogy to high school here. So interviews, this is the poster child for why students change. The student had scored 800 in math on the SAT, 700s in both reading and writing. He had also taken Calculus BC, 5 other advanced placement courses, and had long planned to major in engineering. However, as the student explained to it, when he got to college or high school, right, he was forced to memorize equations, yet engineering is about applications. And he said they really didn't teach it too well. All right? So as he looked ahead to his curriculum, he saw what David Goldberg, engineering professor at UI, calls it the math science death march. The student became a psychology and English double major. Okay? So the pipeline gets even thinner, right? We're constricting it even more because of the way we evaluate teachers and instruction. So we got to keep it open. The way you do it, project-based learning, where you engage students in what they're doing, which I can say more later if you want. It's about engagement, which was said this morning and by Trudy, co-designing project-based learning with people who are applying what teachers are trying to teach in the real world.
Thank you. Dr. Fuller?
Thank you. As you know, the community college is a critical catalyst for economic development. It is important for us to engage business and industry in our discussions in developing credit and non-credit programming. Specific to the semiconductivity industry, we work very closely with our local business, Superpower, and we've expanded collaborations with global foundries to design program and training that help prepare graduates for working in these forms of industries. How do we prepare and how do we know that we are on the mark? We have advisory committees that work collaboratively with our programs to review the curricula, to offer input, provide some assessment, suggest additional skills to help modify the curricula, and to also, sometimes we're able to recruit many of our business industry leaders to teach as adjuncts in the program, which brings a real work experience into the classroom to further expand the learning experience. And also look for very competitive teaching faculty that can bring workforce to the classroom as well as engage the students in the actual active learning. Of course, the pipeline into superconductivity is very limited. So to support the work that Tech Valley High School is doing, we've also reached out with our Schenectady City High School to develop a Smart Scholars Early College High School program with an emphasis on science, technology, engineering, and math. With the support of funding from the Gates Melinda Foundation as well as New York State Education Department, we bring in 50 rising ninth graders and expose them to careers in the sciences to encourage them to consider pursuing careers with jobs that are specific in our area. Our goal is to provide access and to ensure we have programs that are responsive to the needs of business and industry, and to provide the support services to support student success in completing the coursework, graduating, and then being placed into active jobs. It is also important for us to keep that ongoing dialogue with business and industry to ensure that the programs that we are developing are responding to their needs and offer our graduates with the specific skills that they need to be successful within the chosen field.
Great. Thank you. Dr. Schweitzer?
Thanks. I want to thank Trudy for inviting me here today. I really appreciate it. Before I tell you a little bit about myself and my college, I just want to reflect on something that Dan said, because I think it's just so serious and can really undermine this pathway that we're trying to build for students in STEM. And those are what I would group as unintended consequences of the focus that we have right now on these assessments. One unintended consequence that Dan brought up is that we are discouraging students from continuing in high school math and science courses because they will be tested and might perform poorly. We are discouraging them from going on. Another unintended consequence is that because the scores of these kids' tests are are being used to evaluate the schools and the teachers, teachers will not choose to teach in high-risk schools, in urban schools where the kids do poorly. Because nobody's weighting that, nobody's considering that. Everyone is just looking at raw scores. And so when you hear all this rhetoric about testing and holding people accountable, we need to think about the unintended consequences with respect to our society and especially STEM education. Okay, I've said enough. That's my soapbox. I really had to get that out there.
Great.
No, I'm not done.
Oh.
I haven't introduced myself in my car. I just had to do that. Okay.
You had some passion behind it.
I'm sorry. So I'm Laura Schweitzer. I'm the president of Union Graduate College. Union Graduate College is a very small, private, graduate-only college in Schenectady, New York. Used to be part of Union College. We are independent now. It's a very unusual model. I just want to talk a little bit about my background. I am a neurobiologist by training. I really enjoyed hearing the session before this about the advances in imaging and I am a neuroanatomist actually, really exciting. I come to this small private school from very large research institutions. I've always been at large Research One institutions. And I'm going to say something very controversial now, and that controversy is we at a small private school are much better positioned to address workforce needs than large Research One institutions, and I hope to share with you today a little bit about how we do that. We have a very unusual school of engineering, graduate only, and we actually meet the needs of working professional engineers. In other words, a student graduates from an undergraduate program in engineering, they come to the capital region, they get a job, they're working in industry. We build programs around what that working professional engineer needs and what their industry needs. And I'll tell you a little bit more about that later. But our courses are taught in the evening. They're taught by adjuncts. The adjuncts are PhD level engineers who are working here in the capital region. We tap their expertise. They are engineers who hold significant positions in their industries. They have real world experience. They bring that real world experience into the classroom. They have mastered practical problems, and they're teaching engineers who are facing practical problems every day. And we have built these programs to specifically address the needs of industry. Having been at Research One institutions that are, quote, more academic, much more difficult in a large academic institution to reach out and meet the specific needs of industry. We pride ourselves on doing that. I use the word facile. We're small. If someone comes to us with a new need for their industry, we can address that need. So thank you for giving me the opportunity to introduce myself.
Is it okay now that I move on?
Yes,
Chuck?
To put it in perspective of my sitting at this panel, I only wish that my mother and dad could be alive today and have a sense that their son would actually be speaking at a panel for superconductivity. And then obviously my mother and father would quickly ask, what do you know about that subject? And not much. But what I do know about from a chamber perspective is that we are about community. We're about building community. We're about helping with the infrastructure of a community. And that infrastructure necessarily isn't bricks and mortar and cement and asphalt. It's about building a base of knowledge for our employers, which as a Chamber of Commerce, we represent over 1,000 employers in Schenectady County, and that that's from our good friends at GE, right down to a smaller technical company like Superpower, or down to a mom and dad delicatessen. We cross a very, very diverse community, but it's a community of business. But it's that community that we have an interest in building in helping build the pipeline of future employees. And now let me just suggest, and I'll conclude with this, is that we've been talking about the level at high school, at a community college, at a graduate college, or even at a research institution. I think it's all been very well documented that in the United States, we need to start addressing the need for STEM well before then. And it goes back to pre-K, moving in at K to 12, to start addressing our issues. We're not going to solve it tomorrow without addressing what we really need tomorrow, and that's what's interest and direction towards the sciences that we see. So thank you for involving us today.
Great. Now, I have a set of prepared questions, or should I run like with scissors like the moderator before and open it up to the audience? Is that okay with the panel? So I'd like to open it up to the audience. Yes.
I'm Chandra Reese. I happen to be the chair of the local section of the IEEE, which is the Electrical Engineering Association, and I've been deputized in this conversation to represent the ASME, which is the mechanical engineers. We want to help. What can we do? We have lots of people, we have some financial resources, and we have a mandate to go to the schools from middle school up through college, and we can't get in. What can we do? How can we help you so that we can get the people that we need in industry, with using people in industry, or even better, our retirees. We have lots of retirees in this area.
Thank you. That's what needs to be done. So I offer. I wish I had all the answers, and I have some. So I won't. I wish I could take all the names and bring them in. So one thing you can email me. I'll get them all involved in projects as well. But just I know that's not the point of this panel is to look at it systemically. And so what I see in education is this huge wall. The reason you can't get in is because there's a big wall between you and the schools, and they don't want you. That's an exaggeration, okay? All right. Is it being recorded? So I think the answer for us, or the way we've answered that, is to when the school was built, we took the opportunity to build it differently, and that business and industry, community folks were Trudy was at the table when the school was designed. Okay, I had to interview with 8 folks in the business industry before I was hired, even as the principal. Yesterday, Chuck and Jeff were at a meeting at Tech Valley High School with our Business Alliance, where our teachers present projects that they're going to teach, saying to the business community, we don't always know what the applications are. Can you help us engage students in how this stuff is being used in the real world? So the answer to my answer to your question is project-based learning, where projects are co-designed, co-taught, and co-evaluated in collaboration with business and community agencies. So at the table, when the students have to present and defend their work, are people from engineers who are there, okay? When our teachers had to build a project on parabolas because they really weren't sure what an application was, they brought engineers who helped them say, okay, you still have to pass tests on parabolic structures, and you have to pass the Regents exam where that's a standard, right? But let's build solar ovens that can boil water in February, right? And so the engineers were there on the floor with the 9th graders, hammering the solar ovens and giving them feedback, and sometimes making them cry. Right? You got to remember their kids, right? But giving them real world feedback that these kinds of skills that we're talking about aren't fake; they're really needed. And so the answer would be encouraging project-based learning in any district, so that there's something for you to do when you get there, not just come and give money or come on career day, which is okay. There's nothing wrong with that, but that's not likely to keep the pipeline open. What's likely to keep the pipeline open is that when we teach our students how what they're learning is being used. So,
So
sort of
if
a
you-
long-winded answer.
Yeah,
to the,
if you get your contact information
Sure.
to Dan, he can share it with me, because I know dozens of technology teachers that would love to bring you in to help you design,
Absolutely.
evaluate, and
It's in the back.
judge
Yeah.
projects that people work on.
Chandra, I'd like to encourage your associations maybe to look at sooner than ninth grade or wherever level that you're looking at. Start working with the schools earlier on. That's part of the problem here. We haven't excited as well as we should with our young people.
And I would also like to invite you to consider being a part of our summer experiences. We're always looking for summer projects for students to do some career exploration, some job shadowing, co-op internship, as well as engage in some specialized projects with students that have demonstrated the academic competency, and they're just transitioning from 11th to 12th grade, preparing for that next exit from high school. And we would welcome that. If you get me your contact information, I will definitely connect you with the individuals that coordinate that summer experience.
Great. That was worth the price of admission. Other questions? If not, I can go to,
Your comments on the standardized testing and the assessments. I have 3 kids that have gone through the school systems, and my understanding of these assessments and my feeling as to why they're taking place is because the schools have not been able to police themselves. I see a math teacher my child had, who was a younger person, had to have 2 jobs to support his family. He wasn't being paid enough. He was on the union scale, moving up. He wasn't making enough money. He had a wife and a child. On the other hand, I've seen a person who did not belong in that classroom that they couldn't get rid of. So, I mean, I can understand your frustration with assessments, but it's really the only weapon the parents of the students have to try and resolve some of these problems with the teaching. And you're right, there's a huge barrier, there's a wall between the parents and the schools. And they do everything they can to try and keep you out.
I just want to say that I actually believe in assessments. I think they're a good thing. I think the way it's being implemented is totally misguided. So I was in Kentucky during what was called Kentucky Education Reform, and a large part of that reform was assessment. And the way that they did that there was they either used benchmarks within a school, or they used the school as its own benchmark. So for example, an inner city school might score low this year, and if it improved X% next year, they got credit for that. The way it's being implemented, both at the federal level and at the state level in New York, is to just look at raw scores. And I think the unintended consequences of that are going to be extreme.
Well, I agree with you. I mean, teachers who are handing out these assessments to my children at the beginning of the year are saying, leave it blank. Just fill in anything, because they want to look good at the end of the year. And then the kids have figured out that this teacher sucks. He's getting a blank at the end of the year as well. I mean, you're right, it doesn't work, but I can understand what they're trying to do.
Yeah, I understand it. I don't have all the answers, but I wish I did. But I guess a couple things that I don't want to give the message that I'm against testing at all or against accountability. In fact, I think it's crucial. It's important. I think as Dr. Schweitzer pointed out, it's the application of how they're used and what they're used for. So I feel your pain with your some of the teachers in your system. I taught in a very traditional system for 20 years before I had the opportunity to come to Technologists High School. So I get that. I think though that looking at the bigger picture of education regionally and statewide, in New York State, the exams have become the curriculum. What that means is it should be the floor, not the ceiling. It has become the ceiling. In other words, that's the goal and that's the mission of education at the moment. I'm exaggerating. I don't want to give the sense that it's all is lost, because it's not. There's some great programs and great opportunities here in the region. But in general, you're talking about workforce development. Those are big pictures. And what is happening is that those assessments become the focus and the only focus, a very myopic point of view. And what I'm saying is that we need to expand the lens a little bit to not just include content, but to look at how we're teaching deliberately to those other set of skills and how we're assessing them, or not assessing them.
The other thing is the things that can be measured through the assessments are sort of fact-based mostly. We're not able to very well test critical thinking, for example. It's not as easy. And so if you look at the curriculum in science, K through 12, in the United States and you compare it to other countries, what you see in the United States is the curriculum is a mile wide and an inch deep. We're teaching lots of facts and we're testing those facts. If you look at the countries we're competing against, they're really delving deeply into a few core subjects and teaching how to think about, ask questions about that. A lot of scientists in the room, you know that those are the skills, much more than learning the facts, that you're using every day and that we need to be encouraging. Not easily assessed. And so again, unintended consequences, the teaching to the test, the forgetting about the kinds of things that Dan's trying to do in his place where the students are learning real world applications, critical thinking skills, not easy to test. And I don't know, the college presidents are getting together and we hope to have a voice in Washington about this. I'm really worried about the future of this country should we pursue the path that we're on. I really am.
We have one question. Go ahead.
I'm interested in knowing how are the students selected for your school and how large a geographic area do you cover?
Geography, 7 counties. So from far west is Cobleskill, Sharon Springs. As far east is Berlin. Far south is Germantown. North is Shenandoah. So the capital region in Questar 3 BOCES, sort of that area. So it's a huge catchment area. We have about 33 districts represented in our school. The second question was performance.
Well, how are the students selected?
Oh, how are they chosen? It's a blind lottery. All right, we have no ability level testing. So one of the things that's important about that pipeline and keeping it open is that keeping it open for everybody and not just the select few. So we're actually, Tech Valley High School is being studied by University of Chicago right now because they were looking for 20 high schools across the country that were inclusive, that did not select their students based on ability in 9th grade, right? Bronx Science or Stuyvesant or other, right, you might know from New York City. They had a hard time finding 20 schools that were STEM focused and not selected. Okay, so we have everybody. We have 14% of our students have IEPs, individual or special education services. We have our scatter plot of abilities in our small schools pretty wide. We take everybody.
Go ahead.
Schooling, training, or opening a door to a wonderland. If you get hooked by what we do every day, nobody needs to push you. Except maybe
Well, I think
take it easy.
that's part of the whole idea of inspiring and engaging the students early on by really showing them what's behind the science, what is all the great stuff that you could do with this. So, having people come into the classrooms, really doing projects such as what you do there. The programs they have at museums, the Children's Museum in Troy, my side, they do things in a way that engages children. And I think Pradeep was talking about that this morning. That's where you have to start. And then that catches them and they realize that it isn't something so very hard that they can't do, which I think a lot of times is what frightens the kids from doing physics or things like that. They think it's just so hard, but it really is inspiring.
Yeah, I know it was a lifetime ago, but you bring some liquid nitrogen to grade school, and all of a sudden,
Well, a lot of these organizations bring the kids into Superpower, for example, for tours. And we do that kind of thing. We do demonstrations, we show them the factory firsthand and explain, what is it, all this great stuff that you can do with superconductivity. How is it going to change your life, because as they grow up, well, we keep talking 5 years, 5 years, 5 years. By the time they grow up, it will be part of their lives, and that they can be in on the ground floor on something like this.
We have time for one more quick question.
Yes. Some of my best experiences in engineering education were in the lab, where you go down the basement, you work with the motors and generators and all that stuff. What is the status of laboratory courses these days? You're talking about hands-on. This is the real deal. How is it done nowadays?
We make every effort within the community college to have actual instrumentation that is used in business and industry. Like we have a vacuum, actual vacuum that's used pretty prominently within the Nanoscale Superconductivity, and the young men and women actually work on it and then can demonstrate that through some of their co-oping and job shadowing or visiting other labs to actually use those skills. We have an internship here at the College of Nanoscience and Engineering, and our students, this is the second year, and the students that were in their last semester did exceptionally well in demonstrating the actual practical skills, hands-on skills within the labs that they were assigned to do the work. So it's the alignment of actual instrumentation with actual learning skills really makes a difference in the total learning.
So I would just say that the way to do it is to integrate it in everything that you do, so that the tools aren't separated from other content. So one of our approach, thanks to EYP, we have a fab lab, fabrication lab, so that if every project that a student has to do ends in a presentation where they have to present and defend their work, and many of them demand the creation of an artifact, a product of some sort, you integrate both. So we have a shop, okay, hand tools, we have bandsaws, we have a CNC machine, we have a small 3D printer. So that, but we don't teach a course in CNC operation. We teach it to 9th graders along with SolidWorks, and so that over the course of time they can see a variety of those types of applications. And so I think it's not the segregation of technology and tool integration and utility, but it's the integration of it in one's education throughout, so they see it over the course of 4 years and have an opportunity then to dive deeper according to their own self-direction.
And on the graduate level, our students are literally working all day in an environment where they're bringing the learning back. For adult learners, it's been shown that it's extremely important for the learning to be real. And so they're bringing the education that they're learning on a daily basis back to their real life jobs.
All right. You're a wonderful audience, a wonderful panel, so I thank